Hello there, welcome back. This is Richard Gebe and welcome to my channel Richard Gebe Tutorials. In today's class we are going to look at how to calculate WACC wherein you are given a debenture that is redeemable. Okay, so let us look at this question. KPLC is financed as follows. This is an example. KPLC is financed as follows. Equity 10 million, $1 shares quoted at $3.20 ex-div, on which a dividend of 20 cents per share has just been paid. On which a dividend of 20 cents per share has just been paid. Dividends are growing at 8% per annum. Debt $6 million at 10% debentures quoted at 105 x interest. The debenture are redeemable. The debenture what are redeemable in 6 years time at a premium of 10%. Corporation tax is 30%. Required calculate the weighted average cost of capital. So in calculating the weighted average cost of capital, let's start by saying you need four things. You need cost of debt, cost of equity, then you need the weight of debt, the weight of equity, then you can solve the problem. So first we want to calculate our WACC. So if we want to calculate our WACC, let us have the formula for WACC, then we'll be able to see the element we need to calculate in solving that WACC. So basically WACC is going to say WACC will be cost of equity times the weight of equity, equity plus debt, all plus cost of debt multiplied by the weight of debt, equity plus debt. This is what you need in solving your work. You need KE, and if you need KE, you need equity itself, you need KD, and you need debt itself. So let's proceed. First, let us look at KE. So KE, the formula for KE, as you know, DO upon PO. In this question, you have to be mindful that your 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 dividend is given. Okay, this is dividend, and remember your PO as well is given. Your PO is given, and on this it is XDiv. We need XDiv because dividend has been paid. Okay, hadn't been dividend was not yet paid, we should be able to deduct dividend from it, but here dividend has just been paid, so we need this figure to represent our PO. That is the market value. Okay, there's a market value. So but remember here there is growth. Okay, so dividend are growing at 8% per annum. So if there is growth, then definitely our formula will be able to get 1 plus growth, 1 plus growth, all plus growth again. So what is our DO here? Our DO is the dividend that has just been paid, 20 cents. What is our PO? $3.20. But remember our PO $3.20, which is the XDiv. This is in dollars, so you need to convert it into cents. So if you are going to convert it into cents, it will be, if you are going to convert it into cents, it will be 320 cents. Remember here you have 1 plus growth. The growth is 8%. What's the growth? 8%. All plus growth again. All plus growth 8%. So you'll be able to get 20 in bracket 1 plus 0.08 all divided by 320 cents plus 0.08. So solving this one, you'll be able to get 20 in bracket 1.08 all upon 3220 plus 0.08. So after solving that one, this one will give you 21.6 all upon 320 plus 0.08. Okay, you have that one. You go according to what? Board mass. Make sure you divide first, then you can add this one. Your answer will now be 14.75%. Okay, so you now have your KE 14.75%. That's your KE. What do you need next? Next, you need your KD. Okay, so for KD here, you have to be very careful. Here, KD here, remember it's wherein our debt, our debenture is not redeemable, so it's irredeemable. So for us to get our KD, we need to use, we need to do internal rate of return. So in doing internal rate of return, the first thing you consider here, have the time here. You can see the period. You have the period here, and here again, let's say here you have the cash flow, and here you have what? Your discounting factor, DF. What's your discounting factor in this case? Remember, you want to use 10%. So after having that, you're gonna say the year 0, and you have 1 to 6. Why are you doing it this way, 1 to 6 years? Because you know the at the debenture, we have a constant cash flow. Okay, we have a constant cash flow. Then you have at maturity 6, at the 6th year. So first, our investment debentures are quoted what? At 105. So this is going to be like investment, because when you buy, then the money is going out. So this is being considered cash outflow. So in that case, what are you making every year? You're making $10. Remember this 10%. If we have a face value, we have nominal value of 100%. So this is still $10. But remember, on this $10, you have to deduct tax 1 on 30. So if you have to deduct tax, you'll be left with $7. So which is why here you're bringing $7. Okay, you're going to bring what? $7. But remember, you are told that this debenture after 6 years they are redeemed at a premium of 10%. So if it is at a premium, it means it exceeds the nominal, okay, value, which is 100%. If it was at a discount, it means it's below the nominal value. So if it exceeds the nominal value, all you're gonna say is the nominal value plus the premium. So it is going to be redeemed at 110%. So in that light, you want to solve for your um, present value. Here you're going to get present value. So your discounting factor, at 0, it's always 0. And remember, now here you're going to have a constant cash flow 1 year to 6 year, year 1 to year 6, and the cash flow is 7. Since it is constant, you look at your annuity table, and looking at your annuity table, you should be able to get, you look at annuity table under year 6. At year 6, go to year 6 and also look at a discounting factor at what? 10%. And when you do so, you'll be able to get 4.355. And by doing so, remember, as long as the cash flow is constant, use the annuity factor. Okay, use the annuity table instead. But if the cash flow is not constant, then you have to use your normal present value table to discount this one. So for instance, here at the 6th year, you have 110 at which the debt was redeemed. So now go to your discounting factor and apply the same thing there, your present value table. In under the present value table, year 6 at 10% the rate, at 10% the rate, you'll be able to look at and see 0.564. Okay, 0.564. So all you need to do now, your you need to multiply these ones and these ones, then you have them here, then after which you can get them. Okay, so now we go. So multiplying 7 by 4.355, multiplying 7 by 4.355, you'll be able to get 30.49. Remember, don't leave this one behind. Don't leave 105 at 1. So it's still going to be 105. Okay, don't leave it behind. Something by discounting factor, you'll be able to get 62.04. 62.04. So when you do that one and you add it, remember you're going to add all of them. When you add them, you're going to get 12.47. 12.47. Okay, negative. When the discounting factor is higher, then what will happen? The net present value tends to be negative. When the discounting factor is lower, the net present value tends to be positive. So if we are solving for IRR, now we have a discounting factor of 10% and you have negative. So go for a discounting factor that is lower than that for you to have a positive. So all we can say, let's take 7. Okay, let's take 5 for instance. So we are taking another discounting factor of 5%. 5%. So at 5%, you still have 1. Okay. So at 5%, go to your annuity table again. At 5%, year 6, your annuity table, you're going to get 5.076. Then you go to your present value table, you're going to get 0.764. 0.764. 0.764. So you need to get the present value as well. So calculating that, you still have 105, and calculating this one. Remember here, uh, you should be able to understand that you're going to calculate these numbers by these numbers. Okay, here, 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 here. Okay, forgetting about this one because this is just the 10%. Now you want to calculate for the 5%. Okay, good. So you relate them. Here you'll be able to get 35. You'll be able to get 35, not 35, This is 35.53. Here you'll be able to get 80 82.06, and when you add them, take your calculator and add, what you get is going to be 12.59. This time around positive. When you add this one, it takes it this one positive. So you need to solve for your internal rate of return, okay? Your IRR. IRR. Remember, you have A, you have B, you have B. What's your A? So your A is definitely going to be your the rate, okay? The rate of, let's say this time around, the the lower rate. What's your A? Your A is going to be the lower rate. What's the lower rate? Your lower rate is 5%. What's your B? Higher rate is, your higher rate is what? 10%. And what is your A? The net value of your lower rate, 12.47. 12 point, no, the net value of your lower rate is 12 point, the net value of your lower rate is 12.59 positive, and the net value of your higher rate is what? 12.47 negative. So this is what you need to solve your IRR. So now to IRR, you have what? Lower rate plus net present value of the lower rate. I mean, this is the lower rate, okay? The lower rate, A minus B. That's the net present value of what? The higher rate. Net present value of the higher rate. I'm gonna say all in bracket B minus A. What is the B? B also, you also know that B is what? The higher rate. Okay, and A is the lower rate. Okay, so this is the formula for your IRR. So all you need to do, these ones, these values, you insert them into this one, then you're able to solve them. 5%, 5% the lower rate, which is the A, plus what's the net present value of the lower rate? The net present value of the lower rate is 12.59. Remember the 12.59. Then all upon the net present value of the lower rate, which is what? 12.59, 12, 12.59 minus, in bracket, remember this is also minus, the net present value of the what? Higher rate, 12.47. Okay, you have it this way, all in bracket. Then you're gonna say 10%, 10% minus 5%. So you are left with, okay, now this is going to be 0.05% plus 0.05% plus 12.959%, 12.59%, 59, 12.59, I mean, all divided by 12.59 plus 12.47. Why plus? Why it is now changing to plus? Remember, you have two signs here, minus minus, so it's going to affect each other. So here also, you when you minus this one, you're going to get 5%, and that 5% is still 0.05 being translated. So now you need to apply board mass here. How do you apply board mass here? Definitely very easy. From your primary school days, you make sure you treat this one first, then you can add this one. Okay, 0.05 plus 12.59, all divided by 12.59 plus 12 12.47. This one will give you 25.06 multiplied by 0.05. So when you divide 12.59 divided by 25.06, you still have 0.05 equal to plus 0.5024 multiplied by 0.05. So in solving that, you still have 0.05 plus 0.5024 multiplied by 0.05. You get 0.0251, you can say. When you add these two plus 0.05, when you add these two, you should be able to get 0.0751. So this one leaves you with your, it's going to be, when you multiply it by 100%, it's going to be 7.51%. This is your KD, cost of debt. Okay, using the internal rate of return. That's your what, KD. So all you need to solve now is your WACC. Okay, solve your WACC. Come back and solve your WACC. So here we are again. Come to look at your WACC. So you have your KD now. Your KD is what? Your KD is 7.51%. Okay, you have this one. How about the cost of debt? How about the debt and the equity? Okay, the debt and the equity. The debt and the equity, you have to say, okay, for debt, for debt, let's say for equity, for equity, for equity, equity will now be equals to, go back to the question, you have 10 million, okay, 10 million shares. You have 10 million shares, but what is the market value? What's the market value of each share? So 10 million shares multiplied by the market value of each share, which is $3.20. So here you're going to get 10 million at $3.20. You're going to get 32 million. Okay, you're going to get what? 32 million. This is 32 million. How about your debt? Your debt will now be equal to, what will be your debt? Your debt will now be, remember the value of your debt is, you have 6 million, okay, debentures, $6 million debenture. But what is the quoted price? 105. You're gonna take 105. The quoted price is 105. So 6 million quoted at 105. 105. Remember this 105 at the nominal value of 100%. So basically it's going to be 1.05. So 6 million times 1.05 to give you 6.3 million. Okay, so now here you have 32 million back here. Then your D here you have your D here, you have 6.3 million. So when you add both of them, when you add both of them, your when you add both of them, your capital will now be 38.3 million. Okay, this will be your capital. So all you need to do now is to insert. All you need to do is to insert these figures that you have here. These figures you have here, remember these figures you have here, is to insert them into this formula. Is to insert them into this formula above. Okay, but you do insert them into this formula above. So that one will be very, very simple to do. So your WACC WACC will now be, what is your KE? 14.75% multiplied by the weight of your equity. Okay, the weight of your equity. What's your weight? The weight of your equity. Your equity is first 32 million. Add the weight. When you add both of them, you get 38 point. All plus, what's your debt? Cost of debt. Cost of debt is 7.5%, multiplied by the weight of your debt is 6.3 million upon the weight, the total of your capital. You have this one. Okay, so basically you know that you have to convert first the decimal into percentages, then you have all of them. So you can calculate it. 0.1475 multiplied by 32 at 38.3. 32 at 38.3, you have 0.8355 plus 0.075 multiplied by 6.3 at 38.3, you have 0.16449, you can say. Remember, you are at this point. What you need to do, don't forget, you do this first. You have the sum here. You do this second. You have the sum here. Then you can add both of them. Then that will be your WACC. Okay, that will be what? Your WACC. Please remember that. So when you multiply this 14, when you multiply the 14, um, 0.1475 multiplied by this one, you'll be able to get here first. You're able to get 12 0.12, yeah, hold it there. It's a plus. Then you can now solve this one as well. 0.07, 0.0075 times 0.1645, and you're able to get 0.0125 3, 4, and adding both of them, what will happen when you add both of them? You add both of them, basically you're able to get 0.1356 or so 55. Yeah, rounding up matters. So basically you multiply that by 100, your WACC will now be 13.56. Okay, this is how we solve for WACC when our debt is redeemable. I hope you understand this one, and if you have any question, kindly post it in the comment. We'll make sure that we address it. There are more questions coming. Please practice this one, and also make sure you like, you comment, you share, and follow, you subscribe to my channel. Thank you for your support.